So now let's look at the y equals cosecant x. And we know that cosecant x equals 1 over sine x, right? So you can see that this one, cosecant x, is undefined. So this is the one thing you should be careful. It's undefined if sine x equals 0. Sine x equals 0, we know x equals a multiple of pi. Right, so here n is 0 plus minus 1 plus minus 2 and so on. Okay, so this tells you that the cosecant x has infinitely many vertical asymptote which is x equals n times pi. N could be any integers. So the graph, if you draw the graph of cosecant, so we always draw the graph for the sine first because it's 1 over sine, right? So let's draw the graph for sine first. Sine graph would be right. Of course, we have more. Okay, so this is the sine curve, right? So the sine curve here is 1, right? The top is 1, the bottom is -1. Take the values. So the cosecant, we use another color, we use the red color to draw the cosecant, the graph. So the graph is when sine, so we have the vertical asymptote, which is when sine equals 0. So it's here, right? This is the vertical asymptote. And here is the vertical asymptote, right? And here we have the vertical asymptote. And here we have the vertical asymptote. And here we have the vertical asymptote. And here we have the vertical asymptote, right? So the curve would be, because it's 1 over sine. So it's like the reciprocal, right? So we flip the curve, right? So we flip the curve about the peak. But not just flip, because it has a vertical asymptote. So it's like to flip, but it's not the flip. So the graph would be this red curve. So right, the graph, it will touch at the peak and the bottom, right? The graph would be this one. So when we draw the graph for the cosecant, so the first thing is we need to draw the sine first, right? Draw sine first, then find cosecant. Right, we're going to find the cosecant. So let's look at the domain. Domain is all x such that x is not equal to n pi, because n pi, sine of n pi equals 0. So range. So from the red curve, right, it's always above 1 and -1, right? It's always above 1 and -1. Above 1 and below is -1. So the curve, the range is from -infinity to -1. This is included because you have this point is on the -1. A union from 1 to positive infinity. We have vertical asymptote, which is x equals n pi, right? And cosecant and negative x, because 1 over sine. Sine is odd function, so it's odd function. So it would be this one. So it's symmetrical with respect to the origin, right? So this point is here and this point is here if you connect the lines through the origin. Okay, so this is the cosecant. Then we have y equals secant x. So we know that secant x equals 0. So, sorry, not equals, it's equal to 1 over cosine, right? So one thing we should be careful that the secant x is undefined. If cosine equals 0. Cosine x equals 0, we know, which is x equals pi over 2 plus n pi, where n equals 0 plus minus 1 plus minus 2 and so on. Right? So, like we draw the graph for the, so you have the vertical asymptote. X equals pi over 2 plus n pi, right? So the pi over 2, if we know the pi over 2 is here, right? Terminal side is here. If you add pi, it would be here, right? Still, you add a pi, it would be here, right? You add more pi, it will be here. So it's always, you minus pi, it would be here. Minus pi, it would be here. Minus pi, it would be here. So it's always on the y-axis, right? Cosine on the y-axis, the terminal side on the y-axis always be 0. So this is the pi over 2 plus or minus negative, plus or minus n pi. Okay, so we have, like we did, so we still need to draw the graph for the cosine first. Draw cosine first. Then we draw the graph. Then find the cosecant, secant x, right? Okay, so we have cosine. So the graph for the cosine is this one, right? This is 1. -1. This is a 1 period. Right? Okay, so this is the cosine function, right? When cosine equals 0, it would be the vertical asymptote. Vertical asymptote. Vertical asymptote. Vertical asymptote. Vertical asymptote. Right? And the vertical asymptote. And the vertical asymptote. So the graph, we use the orange color, so we like the flip, but not exact the same because we have the vertical asymptote. But for the black curve, there is no vertical asymptote, right? No matter how complicated, no matter how complicated the cotangent, cosecant or secant is, you can always draw the sine of the cosine first, right? Then the zeros of cosine and sine would be the what? Would be the vertical asymptote, right? So from here, from this graph, we can see that the domain is all the x value except the vertical asymptote. So it's all x such that x is not equal to pi over 2 plus n pi, right? So this is pi over 2, right? And here you add pi, add a negative pi, it would be negative pi over 2. Add a negative pi, it would be negative 3 pi over 2, right? If you add a pi, it would be 3 pi over 2, right? Add a pi would be 5 pi over 2, and so on. Then the period is still from negative pi over 2 to 3 pi, which is 2 pi, right? So the period is 2 pi. So the range, sorry, I should say, period is 2 pi, right? So here I forgot to mention this one, the period is 2 pi, which is from 0 to 2 pi, right? Then the graph will be repeated. Right, for this part, the graph will be repeated. The red curve will be repeated, right? So it's 2 pi. The reason is it's 1 over cosine or 1 over sine. So cosine and sine, the period is 2 pi. So cosecant and secant would be 2 pi, also 2 pi. Okay. And we have the vertical asymptote. We have infinitely many vertical asymptote. X equals pi over 2 plus n pi. And this one, because the secant is 1 over cosine, so the cosecant of negative x equals 1 over cosine negative x. Cosine negative x, cosine is an even function, it's 1 over x, so it's equal to secant of x, so it's an even function, right? So even function is with respect to the y-axis, so if we fold it along the y-axis, it will coincide, right? So it's symmetric. With respect to y-axis. Okay. So for example, let's look at one example. We want to graph the 3 cosecant x minus pi. Okay, so in order to draw this graph, we need to draw the graph for 3 sine x minus pi. So 3 sine x minus pi. And 3 is the amplitude, right? Amplitude is 3. So that means the sine function will from negative 3 to 3. And the x minus pi, so it will shift pi, right? So the first thing is we need to draw the graph for this. So of course you can draw it like we did in the sine function. We find the quarter points and draw the graph precisely. But here I give you another idea is we can use the transformation, right? The transformation idea of the transformation. We start from the basic function, the sine function. We just draw a one period, right? So this is the function. So the period is still 2 pi, okay? So this is 2 pi, and this is 0. So 3. Y equals 3 times sine x, which is, we just stretch vertically, right? So here is still 2 pi, but here is negative 3. Here is positive 3, right? Then we get what? Y equals 3 sine x minus pi. So which is, so we move to the left by pi. So here is pi. So this point becomes here, and this point becomes here. 2 pi point would be here, right? So it would be pi, 2 pi, and 3 pi, right? So the graph moved to the left, and to the right by pi units. So it becomes this one. Okay, so this is one period. Of course, we have other period, right? So let's continue. So this is the one period. So we have other period, which is, so this is 4 pi, 5 pi. So you can see it looks like this one, right? I just use the dash line to denote we will extend, right? So here you can extend. And here would be 0 here. Here is negative pi. So we extend it. Sorry. So we extend it. Right. So the graph for the cosecant. So y, this is our graph. We want to know the y equals 3 times cosecant x minus pi. So it would be 3 times 1 over sine, right? So this one would be when sine equals 0, it would be the vertical asymptote. So it's vertical asymptote here. Vertical asymptote is here, right? Vertical asymptote. Vertical asymptote. Vertical asymptote, right? And a vertical asymptote. And a vertical asymptote. So I use another color. I use the green color to draw the graph. So the graph would be, so here is 3. Here is negative 3. So the graph would be this one. The green curve is the graph for the cosecant. So always draw the graph for the sine first, right? We have learned how to draw the graph for sine, right? Okay, so the green color, green curve is the graph for the cosecant x minus pi. Okay, so this is the way we how to draw the graph for the cosecant, right? We don't need to be very precise, right? We don't need to quarter point. We just use the transformation technique, right? Step by step from the basic function to your final function, right? But here is the sine. We draw the sine first, then we can draw the cosecant quickly.